In the gas state, the particles are separated by considerable distances, and they constantly move and collide with one another. There is plenty of free space among the particles of gas. This space can be filled by particles of another gas to make a mixture of gases. Gases readily mix with one another. Evidence of this is provided by air, which is a mixture of a number of gases and contains, among others, oxygen, which we breathe, and carbon dioxide, the gas that we exhale. Because of the constant motion of gas particles and the incessant collisions between them, gases quickly disperse to fill the entire space available.
Smells of perfume and food spread very rapidly. The particles responsible for the sensation of smell are released and mix with air, reaching any place that is accessible to them. We cannot sense the smells until these particles reach our nose. They also have to be numerous enough to cause our sense of smell to react and send a message about it to our brain. The process of diffusion occurs most rapidly in gases. In gases, the distances between particles are comparatively much greater than in liquids or solids. Moreover, gas particles move from place to place very quickly, so they mix with each other very easily. In liquids, the particles have less free space, so the process of diffusion is considerably slower than in gases. In solids, where the movement of particles is very restrained, the process of diffusion is the slowest and may not occur at all.
You can accelerate the movement of particles by heating the mixing substances. Another way to speed up mixing is by mechanical stirring of the substances. We often use this method in everyday life, for example, while preparing drinks. By stirring the contents of the glass, we speed up the mixing of juice and water. We can also observe the phenomenon of mixing in our surroundings. Wind helps smoke to mix with the air, facilitates dispersion of smells in the air, and makes wet laundry dry more quickly. Chemists often prepare solutions of various substances. In the example shown, potassium manganate 7 is the solute, water is the solvent. The solution obtained is a clear liquid in which we cannot see the dissolved substance with the naked eye.
Particles of water approach the particles of solute. They surround the solute particles and pull them out one by one into the solution. A solution forms, which is a mixture of solute particles and solvent particles. Solute particles are often tightly enveloped in a layer of water particles.
An increase in temperature usually accelerates the process of dissolution. Solvent particles begin to move faster, and they collide with these solute particles more often. Apart from that, solute particles gain energy and vibrate more strongly at a higher temperature, which makes it easier to separate them from other solute particles. A finely divided solid dissolves more quickly because crushing a solid into smaller pieces increases the surface area that comes into contact with the solvent particles. As a result of stirring, solvent particles move faster and they collide more frequently with the system of particles forming the solid. In addition, the solute particles separated from the crystal move away more quickly to make room for another batch of solvent particles.